Okay, what is cryptography? Let's go through it over again. Sorry for the break. Now, just like Mr. Joshua said, and also to buttress what he has said, cryptography is like the practice and also the study of techniques for securing communication or any kind of data or information from unauthorized access or what alteration. Now, in simple terms, we can just say when we convert information into a coded format that can only be deciphered or understood by someone who has the correct key or method to decrypt it. Meaning, if I want to send like a love letter to Miss Christiana, but then I'm going to pass that letter to Samuel. Okay, Samuel, let me give this letter to Christiana. I'm sure you know if it's just an envelope, just an ordinary envelope, Samuel can always look at it. In the letter, I might write something like, I love you. Samuel can erase the love, L-O-V-E, and change it to H-A-T-E. That's I hate you. And it's going to pass it to Christiana. Now, the intended message has been altered. Why? I transferred it in plain text. Like I said earlier on, you are going to see, you would have observed that even if you like the concept or you don't like, in the field of cybersecurity, you always deal with cryptography. Challenges that we solved the previous week, you discovered that some flags were actually given to you, but then they were still in base. They were still in base 64, right? Yes, they were still in base 64. So we had to do like further converting. Convert it further to plain text or ASCII representation before it can now make meaning. Look at what we have on the screen. Mere looking at it, I'm sure it does not make any sense, right? HFSJH PZKF. Everything on the screen is looking gibberish. It doesn't make any meaning. Now, what have I done? Let's go to the next slide. Treat your password like your toothbrush. Don't let anyone else use it and get a new one every 6 months. Clifford Stool. This is the plain text of the information. By the time it was encrypted, look at what we have. This cipher text. Let's proceed. The need for cryptography. We all know the need for cryptography. Now, what does it provide? Confidentiality, integrity, authentication, and non-repudiation. I'm going to explain this, although I know it has been explained in the Cisco course, but let me just shed more light on it. Confidentiality, from the word confidential. I already explained to you how you can always get meanings of word in cybersecurity. Confidential means that what something is a secret, even during transmission between parties. From the word confidential, it's actually like for a particular person. It's not just for the general public. Integrity in the idea or in the concept of cybersecurity, integrity means a particular message has not been altered, it has not been changed, probably during transit or not. Like the example I gave before, you have a message saying I love you. Upon getting to the end, the recipient, the message should still be I love you. Nothing like I hate you or I love you all. The moment you are doing something like that, you've already altered the message. And you know it's now very, very serious in the, let's say you are using password. Let's say your password is BATY. The moment you change it to BOTY, forget about it. You're not going to like log in. So we have authentication, verifies the sender who he or she says he or she is. Then no repudiation. Moving further, this is a simple analogy that I explained before. Now let's look at these quick terminologies. or basic terminologies because we always use it from time to time. Plain text, original message. Ciphertext is a coded message. Cipher, the algorithm for transforming plain text to ciphertext. When I mean algorithm, in simple terms, not all of us actually did computer science. In simple terms, you can just call algorithm like technique for transforming plain text to ciphertext. Let me give a simple example. Let's say you want to send, let's use that same example, I love you, as our instance. We want to write it in such a way that even if, like I used Samuel, even if I give it to Samuel, even if he looks at it, it's not going to understand what is written there. Now we want to convert it to a ciphertext. What method am I going to use that Christiana, the recipient of that message, we know that this is the method, because it's about encrypting. Then we have to actually decrypt it. It's a two-way thing. Yeah. I can decide to change to represent I with number 1, L with number 2, O with number 3. But she has to know that I is represented with number 1, L with number 2, and the likes of that. So that's like my algorithm. Another person can have another algorithm and the likes of them, and they're also very popular algorithms that we know. So the key is the info used in cipher, only known to sender and receiver, like I said. Encrypt, converting plain text to ciphertext. Decrypt, recovering plain text from ciphertext. So we have cryptography, cryptanalysis, and cryptology. All these are studies that has to do with encryption, that has to do with cryptography, and the likes of them. Now, cryptanalysis. The previous one is say, how do we characterize crypto systems? Now, cryptographic system can be characterized along these 3 independent dimensions. We have type of encryption operation used, number of keys used, ways in which plain text is processed. Moving to cryptanalysis. Let's quickly perform let's perform a task. It's like a quick task. It has to do with discovering how long it's going to take to get our password. Now, before we do that, let's look at what we are saying here. Typically, the objective of an attacker is to recover the key in use rather than simply to recover the plain text of a single cipher text. Why is this done? The reason why this is done, so that if they get another ciphertext come from that sender, they would know that, okay, this is the key we are going to use to decipher it. Let's say, let's use the assignment again we worked on last week. You discover that you get something, you already know that it's in base 64. You know that that's the algorithm they used, base 64. So you just need to decrypt it from that base 64 to ASCII, or base 64 to like plain text, anyhow you want to call it. There are 2 general approaches. One is cryptanalytic attack. The other one is what? Brute force attack. You must have seen, or you must have read what brute force attack is. But irrespective of what you know, I'll still try to explain brute force attack in a very simple term, or in a very simple way. Let's use the example of a padlock. A door is locked. Then I want to open that door. What do? I take my key. I will try it. That's one random key like that. I will try it. Definitely, most likely it's not going to work. Then I will try another key. Most likely it's not going to work. Then I will keep trying different keys. I can try like 100. Mind you, I don't know the original key that is going to work for that padlock. What does that tell you? That tells you that I'm trying as much as possible to force that thing open, although I don't know the correct key that is going to work for it. That's the same thing that brute force attack is all about. Brute force, we can actually tell from there. We are trying different possible ways to see if the password, the hidden password, is actually like our own password. Look at this example or this instance. Let's assume you have your password as ABC. Then I have my own password as BONINWA24789 asterisk asterisk and the likes of them. Like that's my password. Which one do you think is going to be easy, or which one would be easier to break? Definitely is your own. Your own can easily be gotten. That's after trying A is not going to work. Try B, it's not going to work. C is not going to work. Then try AB, try ABC, and the likes of that. So let's go on with this exercise. We are going to go straight to password monster. So you follow me, because what I'm doing after I'm done with it, you're also going to do yours. You come here. That's what is the this is the password. This is the URL. Passwordmonster.com. Passwordmonster.com. I can as well go to post this thing in case you want to access it from where you are. Check that ask your questions there. It's there. You can use your phone for it. You can see I'm using Windows. You can use your Windows for it. It's not, it's just like an ordinary website. It's not compulsory you use your Kali. So we proceed here. Now input your password. Input any password that you know, probably one of this thing. Don't worry, they're not going to save it. They're not going to save it. Or even if you don't want to put the password, let me say one of your passwords, just put any random stuff. So I'm going to use, let me use this password, BONI. You can see time to crack your password is 0.22 seconds. Now let's use something that is quite long. That's capital letter BONIFACE. Then we have 90099. Then we have, let's use special characters now. You know what constitutes a very strong password. So let's use special characters. Plus, plus, plus. Time to crack your password is 27 years. Good. What it means is that it's not as, this is just like an estimated time to crack your password. What it means is that if I want to brute force against this kind of password, it's going to take me a very long time. Now, some people think, like I've met people that will be like, okay, can you help me hack into this Wi-Fi network? Some they don't really understand like how it works. Apart from the usage of some sophisticated tools, as it stands now, using, let's just say you want to use AirCrackNG, that's a tool in your Kali. Let's say you want to use that tool. Now you want to hack a particular password. You want to hack a particular Wi-Fi, I mean to say. I want to just explain to you what it's like, the way the thing works. First of all, you're going to perform like a man in the middle attack. You are going to like be sitting in between. You're going to be in between. I don't mean when I mean sitting, I don't mean physically. You're going to be in between the host, that's the hotspot or whatever is hosting the Wi-Fi network. You're going to be in between the host and the recipient, or any of the recipients. Now, when packets have been transmitted, you have to disconnect the person and reconnect the person. It happens in split seconds. Now, after that is done, the packet is now being transmitted. Instead of to the person, it's going to be transmitted to you, then to the person. Now, when the packet gets to you, they're going to analyze it. All these things I'm saying, they're not things that will be done manually. There's like a software that automatically does it, which is that AirCrackNG. Now, what does that thing do? It's going to match the password. You know, passwords are always, they're not stored in plain text. They're always stored in encrypted format. It's going to match the password with what? With a dictionary list of passwords. There is a popular dictionary list that we know that contains, I think, over 4 point something billion, 4 point something billion passwords. Let me check. I think it's 4 point, okay, 14 billion. Is this million? This is million. 14 million passwords. Sorry. Okay, good. I know that is something billion. Disregard this information here, please. There are a list of passwords compiled and repeatedly expanded with data leaked over the years. In its most recent iteration, a list of 10 billion plain text passwords. Plain text password. So we have the reason why the number is changing is because it's actually always been updated. It's always been updated. They add more passwords to it over the years. Okay, that being said, like the example I was explaining earlier on, you run a dictionary attack, a dictionary attack against that Wi-Fi network. Now, this is what it does. It's going to keep trying different passwords that are in what rock you. So it's not as if automatically the system will just crack the network server and get the password. That's not how it works. But how it works is it's going to keep matching it to see if the hashed form of that password in your dictionary listing is in line with what is there. So the moment it finds something that is like that, good and fine. Now, where does this time to crack your password, where does it come in? It comes in when you are trying to match. Let's say you've prepared a list yourself in your Kali. You can use Crunch. Crunch is pre-installed in your Kali. Like it comes automatically in your Kali. So the moment you have you can prepare a list of passwords yourself. Yeah, it does it automatically. You set the rules. You can say you want to prepare a list of from 10 letter word to 15 letter word passwords. Different combinations or permutations and combination will be done to get it. So the stronger your password, the stronger the time it takes to crack your password. We'll take a short break now to see if we have let me see from the little I've said, if there are questions.